And we're going to go through a DevSecOps security model for secrets management. And we'll discuss exactly what that means throughout the presentation. But essentially, what it looks like to be an organization with a high level of maturity when it comes to handling, what we call secret sensitive information. So just a quick overview. I'm going to go through quite quickly. I've got a lot to cover. I'll go fairly quickly, but just so you know that everything that we're going through is outlined in reports that we have, I believe you'll have access to too. So we'll go through the problem of hard-coded secrets, exactly what they are. Then we'll actually I'll try and scare you all a little bit by talking about some high-profile breaches. So I think it's always good to relate conceptual ideas and models and maturity to what happens in reality when those fail. So we'll talk about some recent high-profile breaches that have happened as a result of poor secrets management. We'll talk about unsecure development practices, the maturity model that GitGuardian has put together of what we believe companies should strive for in secrets management, in automated detection and remediation. And then I believe we'll go into some Q&As where you'll have an opportunity to ask me some very difficult questions. So let's start with the problem of hard-coded secrets. I like to get everyone onto the same page when I'm using the term secrets of just exactly what I mean when I'm talking about secrets. So I'm talking about what we call digital authentication credentials, and these can really be anything that authenticates us or unencrypts or gives us access to systems, databases, services. So typically these will be things like your API keys to connect to third-party services. It may be security certificates. It may be encryption keys. It can be just credential pairs, username and passwords, to things like databases or to services, browser session tokens, and much more. So really, you can get the idea of this is essentially going to authenticate, going to give access to, to potential malicious actors or to yourself, access to the services that you use. So very quickly, GitGuardian does a lot of research into how much of these secrets actually get exposed in the wild. So one of the places that we look is GitHub. So GitHub is a tool that nearly every developer will be using in their arsenal. They've got more than 80 million developers on GitHub. And it's really a code sharing platform. It's the largest space to share open source tools and repositories and code. And developers often use this as a portfolio. It's unavoidable to kind of have some form of coverage with GitHub as a developer. So what actually GitGuardian does is we scan every single public activity on GitHub. So every time you commit, if you're not familiar with the word commit, you can think of it like upload. Every time a developer commits code publicly to GitHub, GitGuardian will scan it. To get an idea of the volume, there was 1 billion commits last year by 56 million developers. So I said that there's 80 million on GitHub. The difference here is that not all of them pushed code actively publicly last year, but 56 million of them did. So huge numbers. So how many secrets did we actually find? Well, we found 6 million secrets publicly. So this is out in the open, no authentication, not behind any layers, sitting out in the public. We found 6 million credentials here. So huge problem. You don't, as an attacker, it gives you a lot of options to what to do. Now, these range in severity, but I can tell you that 15% of them were for cloud providers. So 15%, over 1 million secrets for cloud providers, which even if it's personal, is still highly problematic and you can do a lot of damage, were leaked last year publicly on GitHub. So let's talk about some high profile incidents now of what's actually happened when these secrets find their way out into the wild. So the first one I want to talk about is CodeCov. I won't go into too much detail about what CodeCov is, but it's a tool that essentially helps you test your application. It tests how much of your application is being tested. So it does a very specific job, and it sits in the CI/CD pipeline in your software delivery process. So what actually happened? So CodeCov ships their product often by a Docker image. A Docker image is basically just a collection, a snapshot of an application and everything it needs to run. So organizations take this Docker image, they plug it into their services to run CodeCov. This Docker image was publicly accessible to everyone. It was stored on Docker Hub. An adversary decided to investigate this Docker image, and they found that actually there was a plain text credential in there. There was a hard-coded secret. Anyone could have found this had they known how to kind of dissect this image, but it's really not that difficult. What this credential gave access to is it gave read-write access to some files that CodeCov were hosting. And this allowed the attackers to actually inject a malicious line of code into a script that they had, a bash script that 20,000 customers were actually using. So 20,000 organizations were using this version of CodeCov. What that script actually did, that malicious line of code actually did, it was buried very well. It'd be very hard to notice it if you were perusing this document, which had over 2,000 lines of code in it. And what the script did is it said, when an organization uses CodeCov in that testing environment, capture all the credentials that are being used by that application in the environment, so all the secrets, and I want you to send them remotely to this address, to the attacker's address. So every time a customer ran, or a user of CodeCov ran that application, it stole the credentials and sent them to the attacker. The main credential that an attacker was after was access to internal version control systems, internal Git repositories, namely. So what we know is that a lot of large companies that were using CodeCov actually had their internal version control systems accessed by this malicious actor. And some of these companies, HashiCorp, Twilio, Rapid7, Monday.com, were all affected by this. So an attacker found a hard-coded credential in a Docker image. They used this to inject some malicious code. And from that, they were able to move laterally into different organizations where they were able to access internal repositories. And in all the companies I just named, HashiCorp, Rapid7, Twilio, there was actually additional secrets in their internal version control systems. So pretty bad scenario here. As I said, 20,000 users were affected by this. So this is one example of a secret entering out into the wild, in this case through a deployment process. Another very recent one happened a couple of weeks ago, which is Uber. You may have heard that Uber suffered a very significant data breach. This one was actually incredibly bad, but luckily for Uber, the adversaries that actually did this, it appears that they were more after making lots of noise than they were of actually achieving malicious goals. But it could have been extremely bad. But what exactly happened? Well, a contractor for Uber, an EXE contractor, had their credentials stolen and put on the black market. I'm not exactly sure the process that happened, but essentially you can buy all kinds of credentials to organizations on the black market. Could have been through a different breach, could have been through phishing. We can assume that one of these reasons was how this contractor had their credentials put on the black market. The attacker then tried to access Uber's internal network via a VPN with these credentials, but were blocked to a multi-factor authentication. So the attack could have stopped there. However, the attacker in this case applied some social engineering to get that contractor to accept the multi-factor authentication request. Exactly how they did this, I'm not sure, but it could have been a phone call of the attacker claiming to be from the security team and that they needed to accept this because they needed access to the account. However it happened, the attacker was then able to gain access into Uber's internal network. Just because they have access to the internal network doesn't mean that they can do horrible things. It's not good. And it's certainly very, very critical, but this was elevated to a whole nother level thanks to some hard-coded secrets that were lying around in Uber's internal network. So they started scanning documents and files, enumerating through all this different data, and they found some PowerShell scripts. So PowerShell scripts are used for various methods of automation. But inside one of these PowerShell scripts, there was a hard-coded credential for the Privilege Access Management System, the PAM system. And this was an admin credential for the PAM system. So the Privilege Access Management System, this is what controls basically access to different third-party activities. It stores your secrets. Admin access to this is worst case scenario. It's basically your password manager and your secrets manager combined, and the attacker then basically had access to everything. So they moved laterally from the PAM system, which happened to be Thycotic, into AWS, GCP, Google Suite, Slack, SentinelOne, HackerOne, and that's what we know of. And at that point, the attacker then started making a lot of noise, posting in Slack channels internally to say that Uber had been hacked. So what we can see here is that there was hard-coded credentials in this PowerShell script. Why they were there? Well, it was admin access to a PAM user, so probably they were automating some processes of adding users. But because of that, worst case scenario, an attacker got access to basically everything. Had they been malicious, it could have been much worse, but it appears the goal was to make more noise and get publicity more than anything. So unsecure software development practices. So we're really building software at a rapid pace now. And there are a couple of things that have really caused and enhanced some insecure practices that have been in place for a long time. that are really being exposed now. So number one is that we're adopting CI/CD pipelines, we're adopting DevOps practices, and this has accelerated software development to a point where it's gone past what we can manage from a security point of view. Deployments are happening daily in large companies. There is so many tools that have automated processes. From a developer can control the entire deployment process from code now. So we're codifying all these different steps, but those coding practices haven't become more secure. And I always like to use the example of all the different third-party tools that we use today. Credit card processing is the easy one to talk about. Are you going to build your own credit card processing, or are you going to implement a company that does this already, Stripe, PayPal, right? You're going to implement a company unless that's the core thing that you want to do. But this is extrapolated to everything now. Managed databases. Maybe we're going to implement search. So we're going to use Algolia. Maybe we don't want to write our own authentication, so we'll use Okta or Auth0. Number of different tools. And these are all kind of used by developers. But then when we go to the DevOps team, they have their own tools. We've got cloud infrastructure. Are you going to build your own servers and host your application, or are you going to put it on AWS? You're going to create a version control system. You're going to use Git. All these different areas. And we can extrapolate this more into microservices and tools that sales and marketing use as well. The key point here is that all of these different tools are external and they all leverage secrets, right? We have to authenticate ourselves. Every single one of these tools is a potential access point for an attacker. Now, that tool may not be critical, but as we saw with Uber, you get access to the internal network, you get access to the internal repository, you get access to the internal messaging system, then you're probably going to be able to find additional sensitive information to move laterally. So we're really accelerating the rapid pace of code, but we're also introducing another level of vulnerabilities in our applications. Why do secrets get exposed? Well, the number one reason, I could skip past this whole slide and then I could just say basically human error, but we can go a little bit deeper. You can imagine a scenario, a developer is quickly trying to get something to work. He hard codes a credential, she hard codes a credential. They commit that. Even if they do the right thing, even if they remove that credential, even if they use environment variables or whatever else we're using, and by the time that goes to code review, there's no sign of anything trouble. Source code is a vulnerability in itself because it keeps the entire history. You do something a year ago, there's a record of that. Hard code a credential on a development branch 500 commits ago, it's still there in the history. It's very hard to delete, especially if you're working in teams, and attackers know this, which is why they're doing it. That's one area. This is particularly true when a repository is made public, right? We deal with a lot of open source companies regularly maintaining open source projects. These often start as internal projects that the company decides to make public for various reasons. Perhaps they don't have the budget to maintain that themselves, so they open source it. But had they done something a year ago in the safety of a private network, well, now they've open sourced it. They've long forgotten about that hard-coded credential, but now it's public. Logs and generated files are another way. You could be doing everything right, but if you come across a problem, as a software developer, as an engineer, you're going to probably produce a debug log so you can figure out where it's went wrong. Guess what's in that debug log? Environment variables, different kinds of secrets. If that gets version controlled, if that gets put in a network somewhere and forgotten about, then that exposes your secrets too. We have sensitive files as well. And we also see a lot of people accidentally pushing things to the wrong areas. On GitHub, if you use it personally and professionally, you actually have the same account. It just sends it to different areas. Makes it really easy to make a mistake and send something to your personal account that was meant to be on a secure network. So what does it look like to have a mature model of managing secrets, a DevSecOps security model? Well, just to emphasize a little bit of the problem that we're actually facing here, I'm going to devolve from public spaces and I'm going to start talking about internal spaces. So if we take a medium-sized company that has an average of 400 developers, so what we see when GitGuardian will investigate the internal networks and code of companies, a company around about 400 developers will typically have about 1,000 secrets rolled across their networks and inside their source code in particular. These 1,000 secrets will occur in an average of 13 different places. Total, 13,000 secrets. That same company probably has 4 AppSec engineers. So now let's talk about if this company is magically able to get visibility to locate all of these secrets, you now have 4 people that have to deal with 13,000 secrets. That's 3,400 secrets each. You do 10 a day for a year. You don't take any holidays, and that's all that you do, and you may get there. But this is the problem, and we can't rely on any one person to stop it. We have to stop this throughout the entire software supply chain. So this is just kind of an idea of why we really need to have maturity in secrets management, because the problem's huge. And even if you can uncover that you actually have a problem, which is kind of like level 3, you're aware of your problem, it's already a little bit late. So I'm going to go through 4 levels that we've come up with that we believe will give you good maturity in handling secrets. So I'll go through each one of these levels and what it involves. But first, before I do that, I just want to say, that when we're talking about this, of course, everyone should be at level 4, right? We should have a fantastic security model. But you can't go from level 0 or level 1 to level 4 immediately. There's no silver bullet. A lot of security vendors will say that their product solves the issue, and then tomorrow you implement it, and then you're fantastic, you're set. The reality that we all know that work in this space is that vendors provide tools, but not complete entire solutions to massive problems. And it's a journey that you need to get there. So tomorrow you implement some great tools, you uncover that you have 13,000 secrets in your network. Well, we need to go through a series of processes to actually get to level 4, and we need to have a plan to get there. Throwing money at the problem doesn't completely solve it, right? We need tools to help us in various ways, but there isn't a silver bullet to this, and doesn't matter how much money you throw at it, if you don't have that plan in place, you won't get there. So what's level 0? You'll be amazed at how many companies are here. And this is basically that speed is more important than security. We manage all our secrets kind of in an unsecure way because it gives all the developers access to them. It gives all the DevOps guys access to them quickly. We don't publish them publicly, but they're lying around everywhere. This is basically where a lot of companies are at, not even understanding, how easily these are accessible. And the argument may be that their source code is private, therefore it's not an issue. But I mean, these are the most sensitive items that we have. Anywhere but a tiny company, you'll have tens and hundreds of developers that have access to this, basically giving them access to your credit cards, giving all those people access to everything, not to mention the fact that security breaches are more and more common. Level 1 is when we're starting to see an understanding of this. It basically means that secrets are still stored on developers' machines in unencrypted ways, so configuration files, but it means that they're not purposely hard-coded in there. But maybe you have an environment variable file that you store in plain text. And in our source control, we have these secrets grouped, so maybe we have a little bit more understanding of where they are, but essentially, they're still in plain text, they're still distributed. And important to know that if something gets into your version control system in your source code, it's going to be backed up into multiple different areas. It's going to be on different developers' machines. It's going to be in wikis. You're going to lose track of it. Now, you also notice there's some kind of grayed out areas there. We have a report on this that you can go into. It has much more granular details. But for the sake of this presentation and the time, I'm just going to focus on the developer environments in the source code. But in the report that you'll have access to, you'll be able to go further into these different areas that we talk about as well. But as we get through some more intermediate levels on here, you might start storing your secrets in appropriate places. For instance, let's say you implement a vault. HashiCorp Vault is one that often comes up, and you're sharing them through a secrets manager. But developers still have access to them. What is critical is you may have policies in place, but you have no idea of whether those policies are being followed. You have a tool, you have a secrets manager, that's great, and you have some idea of how that should be used. But is it being used that way by your developers? Do you know? And then over on the secrets detection side, you may have some manual detection for these secrets, but it's not sophisticated enough that it's going to catch everything. And then in our source control, we'll see that perhaps these are encrypted, but they're checked into our repositories. Just because your secrets are encrypted, doesn't give you a high level of maturity, because that encrypted file is distributed everywhere, and you've given yourself a single point of failure that just requires a secret to be leaked. And if you don't have high levels of maturity in managing secrets yet, the idea of having one single secret that will unlock everything quickly is certainly not great practice. And in terms of secrets detection, you might have some areas that are continuously scanned at different stages, but you don't have that continuous scan over your entire environment. You still don't have visibility as to whether or not your policies that you created are being followed. So level 3, this is the first level where you're not completely screwed. I would say levels 0 to 2 is really you're at an extremely high risk of exposing sensitive information. And that is because you don't have clear visibility over whether the policies are being in place and whether the tools are being used correctly. You have some ideas of how to do it, but level 3 is now where you actually start syncing together some visibility, some tools, and key, what's a really important thing here is some remediation. At level 3, then you have your secrets stored in vaults, and you're only sharing these with your developers through appropriate secrets managers. And here's what's really important. You have rotation policies in place. What this means is that if secrets do get exposed in history that are dated, that you're rotating them regularly enough so that they don't pose an active threat. And also in the development and things, you now started to implement scanning at different stages of the software development lifecycle, not just on your networks, not just on your source code in the server, but actually on the developer's machine. Why that's important is it's going to prevent breaches from happening. If a secret reaches the version control system, it's already game over. But having it on the system means that we can stop the bleeding so much. And we no longer have secrets in our source code. But here's what's key in that secrets detection stance. We're continuously monitoring for hard-coded credentials and stuff on all of our repositories. So this is actually giving us some insights. And we've just started to implement some remediation policies that bring together different teams. And finally, this is the level that we all should be going to. I'm just going to point out kind of what's the key differences between this and level 3. There's number 1, we have dynamic secrets. This is the idea of just in time. Secrets are being created and destroyed just for the lifetime of the purpose that they're being used for. So that means if they get exposed, they're immediately redundant. In terms of that secrets detection stage, what we have is remediation that's automated that involves everyone. I'm going to talk very quickly about remediation and why that's important soon. But this is really the kind of the difference between being that expert level and still having a developing area, is that things should be automated, they should cover everything, and they should involve multiple teams. And automated in the creation of secrets, automated in the rotation of secrets as well. So this is what we really should be aiming for. So how do we build this effective program? An effective detection and remediation program for secrets will include monitoring, detection, alerting, remediation, and analytics. And all of these are important. Yes, we need to be able to detect secrets, but we also need to make sure the alerts are going to the right people and that the remediation process is set up. We go back to those 3,000 secrets that every AppSec engineer has to do. Well, we need to make sure that remediation is spread across different people so that it becomes actually a manageable task. And analytics is really important so that we can get visibility into where the problem is, right? What teams are leaking the most amount of secrets, what projects we need to focus on, what systems are most vulnerable, how long are secrets valid for. All of this we need in our tooling. So GitGuardian has one way of accessing that, getting that visibility into your systems, making sure that you can detect secrets, finding out are secrets valid, what teams, where they're coming from. So that's one way, and that's critical of getting visibility into your systems so that when you do implement systems like vaults and you do implement policies around that, you can actually check that they're being followed up on and the remediation processes are being automated. We need to make sure that we have detection in multiple stages. I touched a little bit on this. Scanning just your server isn't good enough because the threats are already active. We need to define them before on the developer side in your local environment. And we also need to detect them when we deploy applications. So in the case of CodeCov way back, secret was in a Docker application. That was part of the deployment process. Maybe that secret skipped all of those stages and just revealed itself at the deployment stage. So it's, you could have detection on all your developers' machines. You can have detection before they reach your server. They could have detection on your server. Secrets can expose themselves in every single step of the way. So you need to have detection at every single step of the way. And on that local environment side, that's where you're going to make it manageable because that's where you're going to stop the bleeding. Now, I'm nearly finished, but we actually need all these teams to work together. And in secrets detection and having a mature model of managing secrets will involve all of these teams because security teams will be able to see that the policies they've created are being enforced. Teams will be able to implement automated detection so that when something happens, they know about it, security knows about it, and then developers can actually help in this process with literally shifting security left. Shift left is the key word everyone likes to use because they're involved. If a developer leaks a secret, then they need to be part of the remediation process because they're the ones that know what it does. Here's an example of that. If a developer hard codes a credential to something, it gets into your version control system, security team gets an alert, the developer will automatically get a survey to make sure that they can alert, is the secret valid? What was it for? Who leaked it? All that information so that security actually has that at their fingertips. That's what mature remediation looks like. It involves everyone, everything's automated, and everyone's providing information so that the decision makers that need to take action have everything at their hands. So concluding notes, my last slide, secrets management is of three core pillars: processes, people, and tools. So processes is being able to create policies, being able to know what to do when we have breaches. People, we need to train people. We need to raise awareness of this. And of course, we need the tools to help remediate, to help automate, and to help solve this problem. But as I said at the start, there's no silver bullet. All three of these need to be followed if you're going to reach that level 4 maturity. And with that, I'm open to the Q&A session.